Okay, the next thing we have to do is we have to leave note to some important data from the stress and strain testing result. The important data such as yield limit and ultimate load. First, ultimate load, which has the biggest nominal of load before the steel had a failure. You can see which load has the biggest nominal on your data. For example, mine has 3,490 kg force as the biggest nominal of the load, and since I have two data which has the same number, I choose the last one. I choose this one. And then I give note on the side of the row which marks that this one is the ultimate load. Ultimate. Okay, next we give note to the yield limit. The yield limit or beban leleh refers to the point at which the load begins to move slowly. The data indicates that the load, which initially had a nominal value, gradually ceases to be multiplied by 100. Jadi beban leleh ini bisa dilihat di data beban atau load, di mana nominal load ini sudah tidak dikali 100, sudah tidak berkelipatan 100. Okay? So this is my yield limit on my data. From those two data that we have marked, we can input these cells referred from the data here. The yield limit in kilogram force and in Newton, also ultimate load in the unit of kilogram force and in the unit of Newton. Okay, click the load in kilogram force, click enter, and then in Newton, click the cell of yield limit, click enter, and then do the same to the ultimate load. From the tensile test, there were three outputs that we can determine in the end. There were yield strength, maximum tensile strength, and modulus of elasticity. For the yield strength is the stress when the yield load occurs. And the tensile strength is the stress from this row when the ultimate load occurs. The yield strength is Fy. Fy is force yield, and maximum tensile strength is Fu, force ultimate. So you can input the data from the stress row. The yield strength is from the stress where the yield limit occurs, and maximum tensile strength is the stress where the ultimate limit occurs in megapascal. We can determine the modulus of elasticity later in the end. Next, we have to adjust the scale between stress and strain so that AutoCAD will be able to read the data, because this strain data relatively have small nominal, like for example 0.0000 something. So we have to adjust the scale that the curve can be seen. This scaling is only to form a curve pattern. For calculations, we still use the original data or numbers. So click the strain data and multiply the, click the strain data and multiply the numbers by the 10 to the power of 4 equal 10 to the power of 4. And then in here, click the strain numbers and multiply it by this cell. And you have to lock this cell by clicking the F4 button so that the cell won't be shifted. And you can click the edge of the cell so the whole column will be automatically updated with the same formula. And since you have locked the cell from this one by clicking the F4, so you can see in the other cell, this cell won't be shifted to the other cells. For the stress, you don't have to adjust the scale because the nominal of stress are already big enough to be seen. Click the stress and click enter, and then automatically update the whole column. And from here you have got the codes of polyline endpoints, which this polyline endpoint data will be input to the AutoCAD application. And before we go straight to the AutoCAD applications, so make sure that you already have the application installed on your